Good morning, dear students. Today we will consider lecture on Mathematics 1. Today we will consider theme determinants and their properties. Please, next question. Determinants of a square matrix, minus and cofactors, properties of determinants, application of determinants, area of triangle, solution of a system of linear equations, Cramer's rule. And we'll consider class exercise. Determinants. If A is a square matrix of order 1, then determinant A will be equals A11. If A is a square matrix of order 2, then determinants of the second order can be evaluated the next rule. You can see on the screen. Product of the elements lying at first diagonal A11, A22 minus product of elements lying on second diagonal A21, A12. Next, let's consider next example. Evaluate the determinant of the second order 4 minus 3 to 5. In according previous rule, solution. This determinant will be equals product 4 multiplies 5 minus 2 multiplies minus 3. So calculate 20 plus 6 will be equals 26. If A is a square matrix of order 3, then determinants A will be equal the expansion of the elements you can see at the screen. At first, we will consider elements lying at the first row A11, A12 and A13. So we can write A11 multiplies the determinants of second order A22, A23, A32, A33 minus elements A12 multiplies the determinant of second order A21, A23, A31, A33 plus elements A13 multiplies the determinant of second order A21, A22, A31, A32. So this rule expanding along first row. So as a result, we have expression you can see on the screen. Now let us consider next example. Evaluate the determinant 2, 3 minus 5, 7, 1 minus 2, minus 3, 4, 1. Solution. Solution. Now we will apply the previous rule in order to calculate these determinants. We have 2 multiplies the determinant of second order 1 minus 2, 4, 1 minus 3 multiplies the determinant of second order 7 minus 2 minus 3, 1 plus minus 5 multiplies the determinant of second order 7, 1 minus 3, 4. So expanding along first row. So now we have to calculate the 3 determinants of second order. We have 2 multiplies 1 plus 8 minus 3 multiplies 7 minus 6, and minus 5 multiplies 28 plus 3. So we have 2 multiplies 9, we have 18. 7 minus 6 equals 1, multiplies 3, we have minus 3. And minus 5 multiplies 31. We have minus 155. As a result, we have minus 114. Now we will consider next question, minus. If A, this is a matrix of second order, minus 1, 4, 2, 3, then M11, this is a minor of A11, will be equals to 3. M12, this is a minor of A12, will be equals 2. M21, this is a minor of A21, will be equals 4. M22, this is a minor of A22, will be equals to minus 1. If A, this is a matrix of third order, then M11, this is a minor of element A11, will be equals the determinant of the order 2 by 2. Square submatrix is obtained by leaving first row and first column of A. So we have, if we leaving first row and first column of A, we obtain the determinant of second order 0, 0, 3, 4. Evaluate this determinant. We have 0 multiplies 4 minus 3 multiplies 0. So we have 0 minus 0 equals to 0. Similarly, if we have to calculate M23, minor of element A23, we have to eliminate second row and third column. So we obtain the determinant of second order 4, 7, and 2, 3. Evaluating this determinant, we have 12 minus 14. As a result, we have that the minor of element A23 will be equals to minus 2. Next, let's calculate the minor of element A34. In order to calculate this minor, we have to leaving third row and second column. So we obtained the second order determinant 4, 8 minus 9, 0. So let's evaluate this determinant. We have 4 multiplies 0 will be equals to 0, and minus the product of elements lying of second diagonal, minus 9, 8. So we have 72 and minus before them, so we have plus 72. So 0 plus 72, we have 72, and etc. Cofactors. Cofactors Cij, cofactor of elements Aij. in matrix A. So Cij will be equals parenthesis minus 1 in the degree I plus j multiplies minor Mij, where Mij is minor of elements Iaj in matrix A. So let's consider next matrix A of the third order. Now we have to find cofactor of elements A11. Cofactor of elements A11, this is the number. We can calculate it on the previous rule. Parenthesis minus 1 in the degree 1 plus 1 multiplies minor M11. So we have minus 1 in the degree 1 plus 1, and minor M11 will be equals to second order determinants 0, 0, 3, 4. So now let's calculate the determinant. It will be equals to 0 multiplies 4 minus 3 multiplies 0. So we have 0 minus 0 equals to 0. So that means that cofactor of element A11 will be equals to 0. Now we'll consider cofactor of elements A23. Cofactor of elements A23 will be equals parenthesis minus 1 in the degree 2 plus 3 multiplies M23. So minus 4, 7, 2, 3. Now let's calculate the second order determinant. So we have 12 minus 14. 12 minus 14 will be equals minus 2, and sign minus before it. So we have minus 2 will be equals to 2. Now let's find cofactor of elements A32. We will apply previous rule. We can write minus 1 in the degree 3 plus 2 multiplies minor of elements 3, 2. So we have minus 4, 8, minus 9, 0. So it will be equal to minus 72, etc. Value of determinant in terms of minus and cofactors. If a third order determinants, then these determinants will be equals the sum of products minus 1 in the degree I plus j, a ij multiplies minor mij. So it can be written sum 1 from 1 till 3, aij multiplies cij. So let's consider properties of determinants. First property, the value of determinants remains unchanged if its rows and columns are interchanged. Second, if any two rows or columns of a determinant are interchanged, then the value of the determinant is changed by minus sign. Third, if all the elements of row or column is multiplied by a non-zero number k, then the value of the new determinant is k times the value of the original determinants, which also implies 4. If its elements of any row or column consist of two or more terms, then